Hey guys, Elmer the Exponential Elephant here, and today we're going to be graphing exponential functions. Now here's the question. What game do you not want to play with an elephant? Squash!
First thing we're going to do is review an exponential function. That's a function of the form y equals a times b to the x minus h plus k, where a is not equal to 0, b is greater than 0 and not equal to 1, and x, h, and k are all real numbers. So here you can see a bunch of different graphs of exponential functions, and we'll get more into those today. Next thing we're going to do is review exponential growth. That's growth whose rate becomes ever more rapid in proportion to the growing total number or size. This occurs when y equals a times b to the x minus h plus k has an a greater than 0 and a b greater than 1. So here you can see our orange graph represents exponential growth. As your x values increase, your y values increase exponentially. Now, exponential decay is a decline whose rate becomes ever more rapid in proportion to the growing total number or size. This occurs when y equals a times b to the x minus h plus k has an a greater than 0, just like the last one, but the b value is between 0 and 1. So it's going to be a fraction, like a half or 3/4 or something like that. So this green graph right here represents exponential decay. So you can see as your x values increase, your y values decrease exponentially. Next vocabulary term is a parent function. That's the simplest function of a family of functions that preserves the definition or shape of the entire family. So here you can see a bunch of different parent functions, right? It's the most basic function for that family of functions. So a linear function, the most basic function would be y equals x. It has a family of functions though on top of that, which would be like y equals 3x or y equals 8x plus 5 or y equals 100x minus 2. That's the family of functions, but the parent function for that family is y equals x. It's the simplest form. Same thing for quadratic functions, which we'll get into next chapter, cubic functions, and then what we're going to be dealing with today are exponential functions. Now this says y equals e to the x. That's just a number, okay? E is a constant. So what we're going to say is y equals some number to the x power is your parent function for that family of functions. We'll talk about that more today. Transformation is a change in the position of a graph. What you're going to do is you're going to start with a parent function. So in each of these, we can see right here, our orange graph is our parent function. What's going to happen is you're going to have some transformation happen to the graph of the parent function. So here, our parent function is y equals 2 to the x power, or f of x equals 2 to the x power. Now look here, we have y equals, or g of x equals 2 to the x plus 3. So what happens is our h value is actually -3, which means our graph shifts to the left 3 units. Here, h of x is equal to 2 to the x minus 3. Now again, if you recall, our parent function is y equals 2 to the x. And when we have our regular form for our exponential function, it's y equals a times b to the x minus h. So in this case, it's y equals 2 to the x minus 3, which means our h value is 3, which means we're shifting to the right 3. You can see this is representing a horizontal translation, which you're moving left and right. Okay, that's a translation horizontally. A vertical translation would be moving your parent function up or down, and that happens with your k value at the end. So here you can see if we add 3 at the end of that function, rather than like here where we added it in the exponent, if you added it at the end, it shifts your graph up or down. Here, you can see our a value. If it's positive or negative, that affects the graph as well. A reflection in the x-axis or over the x-axis occurs when your a value is negative. So here, our a value is 1. Here, our a value is -1. -1 a value causes the graph to flip or reflect over the x-axis. Now, this over here should look familiar, right? We kind of just talked about exponential growth and decay. Well, what's happening here is that this 2 to the negative x power is the same thing as 1 over 2 to the x, which means our b value, instead of being 2, is now 1/2. Here, our b value is a value greater than 1. That causes it to be exponential growth, where here, our b value, because it's a negative exponent, we have to flip the fraction. It becomes 1 over 2 to the x. That is a b value that's between 0 and 1, so it causes exponential decay. You could also think about this as a reflection over the y-axis. Now let's get a little more in depth into those transformations. So this is how you determine if your graph has any transformations. You're going to look at your exponential function. Your A value is going to determine whether your graph is going just normally like an exponential growth or decay graph, or whether it's reflected over the x-axis. So if your A value, the number in front, is positive, it's just going to be a normal exponential growth or decay graph. If your A value is negative, that's going to cause your graph to reflect over the x-axis or in the x-axis. Okay, that means the same thing. If your A value is greater than 1 or less than -1, so it's a really big number like 100 or -100, it's going to cause your graph to stretch. So what that means is that your graph is going to be really steep, either going up if A is greater than 1 or going down if A is less than -1. If A is between -1 and 1, so let's say it's a fraction like -1/2 or +1/3. If A is between -1 and 1, it's going to cause your graph to get compressed, which means it's going to be flatter. It's not going to be very steep. It's going to go up very slowly. So that's what happens with your A value. That's what your A value does to your parent function. Your B value, we said if B is greater than 1, that means that it's exponential growth. And if B is between 0 and 1, that means it's going to be exponential decay. In this chapter, we're not going to be dealing with any B values that are negative. If your function is negative, that's going to be your A value that's doing that. Your H value determines horizontal translation. So horizontal translation is moving your parent function to the left or right. So if your H value is positive, it's going to move your graph to the right. If your H value is negative, it's going to move your graph to the left, your parent function. Now the issue here is this X minus H. That means that it's basically going to be the opposite of whatever you see. So if you have B to the X plus 1, that's an H value of -1. If you have B to the X minus 5, that's an H value of 5. So you have to determine that, and we'll practice that a bunch, so don't worry about that. Your K value determines how much to vertically translate your parent function. K, whatever's added on or subtracted on at the end, that's going to tell you how much to shift your graph up or down.
What did the elephant say to her son when he misbehaved? Tusk, tusk! Example time.
Okay, example 1 says, given the exponential function, determine the parent function, all transformations, and whether it represents exponential growth or decay. So given our function here, what we want to do first is figure out what's our A value, what's our B value, what's our H value, and what's our K value. So here, our A value is the number that's multiplied in front. Here, there is no number, which means our A value is 1. Our B value is whatever number is being raised to the exponent, the variable. Okay, so in this case, that would be this 1/5. So our B value is going to be 1/5. Our H value is going to be whatever is in the exponent with that X. And it's going to be the opposite of whatever you see. So in this case, that would be this -2. So our H value then would be +2 because it's the opposite of whatever you see. And then down here, this K value is going to be whatever's added or subtracted at the end. So that would be 4. Now we can go through and answer our question. So it says determine the parent function. So the parent function is going to be the most basic form of this function, which in this case is going to be f of x is equal to 1/5 to the x power. It's just ignoring your A value, your H value, and your K value. So if you take away your A value, H value, and K value, that's your parent function. Transformations. So that is where we talk about our A value, our H value, and our K value. So the A value is 1. That doesn't affect the graph at all. It doesn't make it reflect, it doesn't stretch it or compress it, so we leave that alone. H is 2. Now what that means is you're going to shift the graph horizontally to the right 2 units. That's a horizontal translation to the right 2 units. Your K value, since it's +4, is going to shift your graph up 4 units. So it's a vertical translation up 4 units. Lastly, growth or decay. That's your B value. So we look at our B value, it's between 0 and 1, which means that's going to be exponential decay. So your graph is going to go down and to the right. B, we have this function. Again, let's talk about our A, our B, our H, and our K. So our A value is this number in front, that would be -4. Our B value is whatever's being raised to our variable exponent, so that would be 2. Our H value is the opposite of whatever you see added or subtracted in that exponent, so +1, so that means our H value is going to be -1. And then our K value is going to be whatever's added or subtracted at the end, so that would be -3. Now we go through and answer our questions. What's the parent function? So take away your A value, your H value, and your K value. What do you get? G of x is equal to 2 to the x power. That's your parent function. Next, transformations. So we start with our A value. Is it positive or negative? It's negative. That means it's going to be a reflection over the x-axis. since it's -4, the negative reflects it over the x-axis, and the 4 makes it so that it stretches the graph vertically. So it's a vertical stretch by a factor of 4. Now, why not -4? Because the negative is the reflection over the x-axis. The 4 just tells you how much to stretch it going down now, since it reflected over the x-axis. The h value, what does that tell you? Well, h is -1. That means it's going to be a horizontal translation to the left 1 unit. And then since your k value is -3, that's going to be a vertical translation. It shifts your graph down 3 units. So it's going to be a vertical translation down 3 units. Lastly, growth or decay. We look at our b value. It's 2. That is a number that is greater than 1. Therefore, your graph is going to represent exponential growth.
What did Tarzan say when he saw a herd of elephants? Look, a herd of elephants! You try.
Okay, doing the same thing here. So first, what's our a value? Well, it looks like this technically is -1 times 7 to the x plus 5 power. So our a value is technically -1. Our b value is going to be 7, because that's the number that's being raised to our exponent. Our h value is the opposite of whatever you see added or subtracted in that exponent. So instead of being +5, it's going to be -5. And then our k value is going to be what's added or subtracted at the end, 10. So then, determine the parent function. So take away the a value, the h value, and the k value. What are you left with? Well, that's p of x is equal to 7 to the x power. That's your parent function. Now let's take a look at the transformations that are happening to this parent function. So what's our a value? It's -1. Since it's negative, that means it's going to be a reflection over the x-axis. So instead of going up and to the right, it's going to go down and to the right like that. Your h value, that is -5. That means it's going to be a horizontal translation to the left 5 units. And then your k value is +10. That's going to be a vertical translation up 10 units. Now, is it growth or decay? That's where you look at your b value. So your b value is 7 in this case. That means since it's bigger than 1, it's going to be exponential growth. For part B, again, we look at our a, b, h, and k value. So our a value is going to be 9. Our b value, the number being raised to the exponent, is going to be this 0.6 here. Our h value, the opposite of whatever you see added or subtracted in that exponent, is going to be +1 because it's the opposite. And then whatever's added or subtracted at the end, that's your k value, so that would be -8. Now let's go through and answer our question. So our parent function, if you were to take away a, h, and k, what are you left with? That's r of x is equal to 0.6 to the x power. That's your parent function. Now let's take a look at the transformations that are happening to this parent function. So your a value is 9. Okay, since it's positive, there's no reflection. But since it's bigger than 1, it's going to be a vertical stretch by a factor of 9. Then what we have to look at is your h value. Since it's +1, that's going to be a horizontal translation to the right 1 unit. Your k value is going to tell you how much to shift your graph up or down. So since it's -8, you're going to shift your graph down vertically 8 units. And then lastly, we look at our b value. What does our b value tell us? Whether it's growth or decay. So since your b value is 0.6, that's a number between 0 and 1, this graph is going to represent exponential decay. So it's going to go down and to the right. Now, example 2 says determine a, b, h, and k. Decide whether the graph represents exponential growth or decay, then graph the exponential function. So let's get to it. Determine a, b, h, and k. So here, our a value is the number that's multiplied out front. There isn't one, so it's going to be 1 in this case. Our b value is the number being raised to our variable exponent, so that's going to be this 4. Our h value is whatever is added or subtracted to our exponent, so that's nothing here, so that would be 0. And our k value is whatever is added or subtracted at the end, so in this case that would be 0 also, because there's nothing. Next, exponential growth or decay. Well, your b value is 4, that's greater than 1, therefore this is exponential growth. And then lastly, we're going to graph our given function. Now, some teachers teach us a little bit differently. I, in this set of notes, am just going to use for our x values -2, -1, 0, 1, and 2 each time. You can do that every time and plot those points, and they will be points on the graph. Okay, some teachers teach it where you have to use these given x values and then apply the given transformation to those x values and create a whole new chart. I'm just going to have you do this today. So, -2. What we're going to do is we're going to plug that in for x in the original function. F of x is equal to 4 to the x power. So we take -2, plug it in for x. This is the same thing as 1 over 4 to the second power. That's how you get a negative exponent to be positive. You flip it, and then you go ahead and square that. You get 1/16. That's the y value that corresponds with -2. We then go over to our graph and graph the point -2, 1/16. So -2, 1/16 is just a little bit above the x-axis, so it's going to be somewhere right there. -1, we plug that into the function. So f of -1, 4 to the negative first power. That's the same thing as 1 over 4 to the positive first power, which is the same thing as 1/4. So we make that our y value that goes with -1. Now we plot the point, -1 and 1/4. So -1, 1/4 would be somewhere right here. 0. Plug that into the function for x. What do we get for y? 4 to the 0 power is just 1, right? Anything to the 0 power is 1. So our point now is 0, 1. So we plot the point 0, 1. And then 1 we plug into the function. If we were to plug that in, 4 to the first power is just going to be 4. So that y value that corresponds with 1 is going to be 4. So we go over the point 1, 4, and we put a point. And then lastly, we're going to plug in 2 to the function for x. So 4 to the second power is going to be 16. That's the y value that corresponds with this x value. So 2, 16. That's off the graph, so we're not going to plot that. We're just going to draw our line going through these points right here, our curve, our exponential growth curve, and it looks something like this.
What do you get when you cross a herd of elephants and a group of fish? Swimming trunks! You try.
Okay, doing the same thing here. First, A, B, H, and K. What's our A value? It's the number that's multiplied out front. So in this case, since there's no parentheses around the -3, our A value would be this -1 that's out here. Our B value is going to be whatever's being raised to that variable. So in this case, that would be the 3. Our H value is whatever's added or subtracted in our exponent, the opposite of that. So that would in this case be 0. And then K value is whatever's added or subtracted at the end. So that would also be 0. We need to decide, is this exponential growth or decay? Well, your B value is 3. Since 3 is greater than 1, this is going to be exponential growth. The only problem is it's not going to go up and to the right because your A value is negative, which causes a reflection over the x-axis. So it's actually going to go down like that exponentially. So let's go ahead and graph this now. Here, I said our x values are going to be -2, -1, 0, 1, and 2. We're going to plug those into the function for x, see what we get for y. So let's plug in -2 first. -3 to the negative second power. Remember, there's no parentheses around the -3, which means when we flip this over, it becomes 1 over -3 squared. We're going to square the 3 first and then tack on the negative. So it becomes -1/9. That's the y value that corresponds with this -2. So I plot the point -2, -1/9. So I go over to -2, down to -1/9, which is somewhere right here close to the x-axis. There you go. Now let's plug in -1. So -1, we have -3 to the negative first power. So in order to get this negative exponent positive, I move it to the denominator. So it becomes 1 over -3 to the positive first power, which is just 1 over -3 or -1/3. So I go ahead and plot the point -1, -1/3, which is somewhere right here. Then I go to 0, plug in 0 for x, and I get -3 to the 0 power. Now again, remember anything to the 0 power is 1, but since this is not in parentheses, this -3 is not in parentheses, we're going to do 3 to the 0 power, which is going to be 1. Then you tack on the negative, and it becomes -1. So we plot the point 0, -1. So we go 0 on the x-axis, down -1 on the y-axis, put a point 1. We're going to plug in 1 for the function, and that's just -3. So we got the point 1, -3. So we go over to 1 on our x-axis, down to -3 on the y-axis, put a point. And then lastly, 2 we plug in. We're going to square the 3 and then tack on the negative, so it becomes -9. Remember, if this were in parentheses, it would be +9. But since it's not, you square the 3 and then tack on the negative, so it becomes -9. So we go over to 2 on the x-axis, down to -9 on the y-axis, put a point, draw a curve going through those points, and you see your graph there. Example 3, doing the same thing. So first, we want to figure out what's our A, what's our B, H, and K. So our A values, the number that's multiplied on out front, there isn't one, which means your A value is 1. Your B value, whatever's being raised to that variable exponent, so that's going to be 0.5. Your H value, the opposite of whatever you add or subtract in your exponent, so there's nothing there, so your H value is 0. K value, whatever's added or subtracted at the end, so in this case that would be 1. Next, exponential growth or decay. We look at our given B value, it's between 0 and 1, which means it's going to be exponential decay. So it should be going down and to the right like that. Okay, this is a good way to check your work. Next, we're going to graph it, and we said our x values that we're going to plug in today are -2, -1, 0, 1, and 2. So let's go ahead and do that. We plug in -2 to the function for x. We get 0.5 to the -2 plus 1. Now, in order to make this negative exponent positive, right, we got to flip this guy right here, so it becomes 1 over 0.5 to the +2, which is 1 over 0.25. Which, if you actually divide that, becomes 4. And then you get 4 plus 1, which is 5. So that is going to be the y value that corresponds with this -2. Now I plot this point, -2 on the x-axis, up 5 on the y-axis, and we put a point. Next, -1 we plug in. So if I were to plug in -1 here, 0.5 to the negative first power, to make this negative exponent positive, got to flip it, so it becomes 1 over 0.5 to the first. Now what is 1 over 0.5? That's actually going to be 2, and then I add that 1 at the end, so I get 3 as the y value that goes with my -1 x value. So I go over to -1 on the x-axis, up 3 to my y value, and I put a point. Next, 0. Plug that in. 0.5 to the 0 is going to be 1, because anything to 0 power is 1. Plus 1 gives you 2. So 0, 2 is the next point I'm going to graph. Over 0 on the x-axis, up 2 on the y-axis, put a point. Then I plug in 1. So 0.5 to the first is just 0.5, right? 0.5 plus 1 is 1.5. So I go over to 1 on my x-axis, up to 1.5, which is somewhere between 1 and 2 on my y-axis, and I put a point. Next, 2. Plug that in. What's 0.5 squared? That's 0.25. And then 0.25 plus 1 is 1.25. So I go over to 2 on my x-axis, up 1.25 on my y-axis, so somewhere right above a y value of 1, and I put a point. Now I can draw my curve going through those, my exponential decay curve, and you can see, yeah, there it is. Also note here that the k value is 1, and that shifts your parent function up 1 unit, which is why this exponential decay graph would normally go down to the x-axis, but it actually shifts up 1. Cool.
What do you call an elephant covered in mud? Dirty! You try.
Okay, again, we're looking for our A, our B, our H, and our K. So the A is the number multiplied out front, that's the 2. Your B value is the number being raised to this variable exponent, that would be the 1/3. Your H value is the opposite of whatever's added or subtracted in your exponent, so that would be 0 in this case because there's nothing added or subtracted. And then K is whatever's added or subtracted at the end, which is, again, nothing, so that would be 0. Cool. Now, this is exponential decay because our function has a b value that is between 0 and 1. It's not greater than 1. And now we're going to graph it. So we said -2, -1, 0, 1, and 2. Those are the x values we're plugging in. So let's plug them in. If I were to plug in -2 for x here, 1/3 to the -2 power. Remember, what happens actually if you have a fraction raised to an exponent, that exponent has to go to the numerator and denominator. And to make a negative exponent positive, you got to flip it. So this 1 to the -2 goes to the denominator, becomes 1 to the +2. 3 to the -2 goes to the numerator, becomes 3 to the +2. Now you square those and you multiply to the 2, you end up getting 18. So that's the y value that goes here. So we go over to -2 up to 18. Oh, that's off the graph, so we're not going to graph that. -1, I'm going to plug in -1 for x. So again, the exponent goes to the numerator and denominator. Got to flip these because we need to make them positive exponents. 3 to the first is 3, and then 3 times 2 gives you 6. So that is the y value that goes with an x value of -1. So we go over to -1 up to 6 on the y-axis, put a point. 0, plug in 0. What's 1/3 to the 0 power? That's 1, because anything to the 0 power is 1. We then multiply 2 times 1, and that gives you 2. So 0, 2 is the next point we're going to graph. So over 0 up 2, put a point. 1, plug in 1. So 1/3 to the first power is just 1/3. Then we take 1/3, multiply it by 2, and you get 2/3, because 2 is the same as 2 over 1. So 2 times the 1 gives you 2, 1 times the 3 gives you 3. That's how you get 2/3. Now, plot the point 1, 2/3. So we go over 1, up 2/3. So 2/3 of the way up to 1. So somewhere in there. And then 2, plug that in. So 2, we're going to square the numerator and denominator here. So 1 squared gives you 1, 3 squared gives you 9. Now we multiply 2 times 1/9. Again, 2 is the same as 2 over 1. So you get 2 over 9 as your answer. So 2/9 is your y value. So you go over 2 up 2/9, which is somewhere close to the x-axis here. And now we're going to graph our exponential decay graph, which looks something like this. Now example 4, we're doing the same thing. Let's figure out our A, B, H, and K. What's the number multiplied out front? There isn't one, so it would be 1. What's our B value? That's the number being raised to our variable exponents. That would be 2 in this case. What's our H value? The opposite of whatever you see added or subtracted to your exponent. So that would be 1 in this case, right? The opposite of whatever you see added or subtracted to your exponent. And then K, whatever's added or subtracted at the end, there isn't anything, so that would be 0. Next, exponential growth or decay. Since your B value is greater than 1, we're going to say this is exponential growth. And now we're going to graph the given function. And we said our x values that we're going to plug in are -2, -1, 0, 1, and 2. So let's go ahead and plug those into the given function. We'll start with -2. So if I plug in -2 to our given function here, -2 minus 1 actually gives you -3. So we have 2 to the -3rd power. So to make a negative exponent positive, you flip that and it becomes 1 over 2 to the positive third, which is 1 over 8. So that's the y value that goes with an x value of negative 2. So we go over to negative 2 up 1/8, which is very close to the x-axis. You put a point. Negative 1, plug that into the function for x. What's negative 1 minus 1? That's negative 2. Now what's 2 to the negative 2? Well, we have to flip that, so it becomes 1 over 2 to the positive 2. And now 2 squared we know is 4, so 1/4 is the y value that goes with an x value of negative 1. So we go over to negative 1, up 1/4. Now 0, if I were to plug in 0 here, 0 minus 1 is going to be negative 1. So 2 to the negative first, got to flip that again, so it becomes 1 over 2 to the positive first, which is just 1/2. So 0 comma 1/2 is going to be our next point. And then after that, we plug in 1 for our function for x. So what's 1 minus 1? Well, that becomes 0, right? So we get 2 to the 0 power. And what's 2 to the 0 power? That is 1. So we plot the point 1 comma 1. And then lastly, 2, if I were to plug that in the function, 2 minus 1, I end up getting 1. So 2 to the first then is just going to be 2. So I plot the point 2 comma 2. Sweet. Now I draw my exponential growth curve going through that, and you're done.
What did the elephant do when he hurt his toe? Called a tow truck. You try.
Okay, doing the same thing here. Your a value, whatever's multiplied to the front, so that would, in this case, be 1, because there isn't anything. Your b value, the number that's being raised to your exponent, that's going to be 0.8. Your h value, the opposite of whatever's added or subtracted to your exponent, so that would be negative 3 in this case, because that's the opposite of this plus 3. And then k, whatever's added or subtracted at the end, that's nothing, so that would be 0. Next, exponential growth or decay. Well, your b value is between 0 and 1, so that's going to be exponential decay. Then, we're going to graph it. We said x values, negative 2, negative 1, 0, 1, and 2. So let's plug these in. If I were to plug in negative 2 for my x value, negative 2 plus 3 is 1, so 0.8 to the first power is 0.8. So that's going to be our y value that goes with negative 2. So we go over to negative 2, up 0.8, and we put a point. Next, negative 1. If I were to plug that in for x, what's negative 1 plus 3? That's going to be 2. So what is 0.8 squared? That's going to give you 0.64. So we get negative 1 comma 0.64. So we go over to negative 1, up 0.64, like almost halfway up, and put a point. Next, we're going to plug in 0 for x. So if I plug in 0, what's 0 plus 3? That's 3. And then 0.8 to the third power is going to give you 0.512. So we plot the point 0 comma 0.512. So we go over to 0 on our x-axis up to 0.512, which is about halfway up because 0.5 is about halfway. Next, we plug in 1. 1 plus 3 in our exponent is going to give us 4, and then 0.8 to the fourth power is going to give us 0.4096. So now we plot the point 1 comma 0.4096. So we go over to 1 on our x-axis up 0.4, which is a little bit less than halfway up. Put a point. Lastly, we're going to plug in 2 for x. So 2 plus 3 in our exponent is going to give you 5. And what's 0.8 to the fifth power? That's going to be 0.32768. So we plot the point 2 comma 0.32768. Again, you have no idea where that actually is, so you just kind of estimate. 0.3 is close to a third, so we go up a third of the way on our y-axis at x is equal to 2. Put a point. Now we draw an exponential decay curve going through that, and we get something that looks like this. Now, again, the reason this looks like this is because it's exponential decay, and our graph has shifted to the left 3 units, which is why it normally would be somewhere right here, but it's a little bit moved to the left because of our translation.